Hey everybody, my name is Alan Garver. I'm a professional services consultant with Amazon. And here we're talking about DevOps pipeline security. We got a bunch of stuff to get through. We'll kind of go through it quick, but we're going to give you, in the session today, some tidbits about ways that we work with different customers in the enterprise services space to secure pipelines. So we're going to talk about a bunch of that detail, but first we want to talk a little bit about the motivation for the talk today. We work a lot at AWS and professional services. We work a lot with financial services customers in the enterprise space in different areas, doing continuous delivery and DevOps and security and microservices decomposition and things like this. And so we wanted to talk a little bit about how DevOps pipelines and things like this are typically part of a more holistic project and give you some tidbits on what that looks like. So today we're going to talk a little bit about financial services customers specifically and the specific challenges that we have there. We're working with several different customers in this space, along with Stelligent, a business partner, and specifically one customer who's here to talk a little bit about what they're doing here in the space before we jump into the tidbits is Citi. And so at Citi, they're doing some interesting work in the space, and we have Jamie Greco here. She's a senior vice president at Citi. She'll talk a little bit about what they're doing, and then we'll jump into it. So here's Jamie.
Thanks. How's everyone doing today? Good? Good. Okay, that's better. This is a lot less intimidating than, what, the 1,500 people in the big hall on Monday? So we can be a little bit more casual, I think. I'm just going to take a few minutes and talk through all of the initiatives that we have going on at Citi, and then turn it back over to Alan and Chuck to really get into the meat of what we're doing and really get into the things that you guys want to see, which is all the code happening on the screen. So I won't take up too much of your time before I turn it back over to them. But I wanted to give you a preface of the entire initiative and the holistic approach that we're taking and how even something and how what Chuck and Alan are doing for us ties into that entire holistic approach. Okay, so how many of you work in financial services industry? Anybody? How many of you have huge monolithic mainframe applications to deal with? Yeah, yes. It's a challenge, isn't it? Yep. So at Citi, we kicked off an entire initiative this year to really focus on decomposing our monoliths, building out microservices and leveraging the services that AWS has to offer to release features to our customers faster. So what Alan and Chuck are going to go through is that pipeline on how we're focusing on the DevOps piece of it to release customers to our features to our customers faster. But I wanted to touch on the entire initiative because it's important to understand everything in the transformation that we're going through to implement what Alan and Chuck are helping us with. So we're focusing on decomposing those monoliths, building microservices. Our goal is to automate the entire pipeline, including the data protection piece of it to make us more efficient and more secure. And we're doing this by tackling three different things. First, the decomposition of the monolith. Second, we're setting up agile teams that are truly agile, autonomous teams to work through the decomp and the refactor and owning their own products. And then the third piece is by using the tools that AWS brings us to automate the entire pipeline to help our teams move faster. So the first slide that we're going to go through here is just the decomp of the mainframe. Anybody else dealing with this right now, building out microservices? Yep, new buzzword. It's all microservices around the office. Perfect, yep. So we're going down the same journey. We're focusing on decoupling the presentation layer from the business logic right now, and then decoupling the business logic out of the ESB layer and the mainframe layer to build those atomic services that each of our agile teams that we're going to talk about here in a minute will own and own end-to-end. So they'll own everything from deploying the tech stack to building the code, testing the code, and deploying and owning post-launch. So the other initiative that we're going through right now is just building out those autonomous Scrum teams. I don't know if any of you are making the move to Agile or you're doing kind of Waterdile right now. Waterdile? Yeah, I've heard it called many things. We're really pushing to get to that true Agile model where our teams can do it all. We want our teams to stand up their tech stacks, own their code, test their code, deploy their code, and we want them to be secure in the process of doing all of this. So Alan and Chuck are really going to talk you through that security piece of it and that compliance piece of it to make sure what our teams are building is secure so that when we deploy it, we don't have issues in our production environment, and the features that we can release to our customers faster are available all the time. Okay. So by doing this, by decomping our monolith, by building out the Scrum teams, by building the microservices, and really empowering our teams through the pipeline, we're able to move faster, we're able to keep our costs down, and we're able to get a higher quality out of it. So I'll turn it over to Alan and Chuck and really go through that pipeline piece of it. They'll show you what we're working on to make sure that we're secure in that entire process.
Great. Thanks, Jamie. All right, so let's jump into some good stuff. So before we get into some of the tips, tricks, techniques we're implementing in different places, I thought we'd take a minute, even though this is a more technical level course, we thought we'd level set a little bit on what a pipeline is, talk a little bit about the components of it before we sort of jump into some of the techniques. So I assume many of you are familiar with pipelines in general as a capability, but essentially a continuous delivery pipeline or a DevOps pipeline is a set of automation. It's a secure transport that we use to take code from some source code repository out to a set of running infrastructure. And so this transport can be sort of customized, divided into stages, built around your own software development lifecycle, but it's designed to provide the automation platform and the things that you need to do from an automation perspective to deliver code to running infrastructure, but also catch failures, right? To test things that are happening not just from an infrastructure perspective, but from an application perspective as well. And its mission, or one of the missions that it has, is to provide fast feedback to the developer, right? So we want the developer to get as close to the time of commit on that code, feedback about whatever the bug or the error is that caused the failure. And so the continuous pipeline serves well in this space. At AWS, we have a service called AWS Code Pipeline. It is used to, you can log into it and basically very quickly model and set up your own release stages. You get to view at a glance, so the progress of things that are flowing through this pipeline. But in each stage, we kind of do things like deploy a server or compile code or do different things, and then we might do static code analysis on a piece of code. We might do spec testing against some infrastructure code, and we might even do performance and capacity testing in certain stages. AWS Code Pipeline integrates with your favorite tools today, so there's a lot of integrations with things like Git and various other services that it seamlessly integrates with, but it also integrates well with other AWS services like Code Commit and Code Deploy. So one of the first things we wanted to one of the first tips that we wanted to kind of jump into was about building a secure build artifact repository. So a build artifact repository is every time your sort of pipeline is running, in a lot of cases, the pipeline will need to do things with code, turn them into some sort of modified artifact, and then consume that code or that modified binary file or whatever it is later in the pipeline. And so the build artifact repository becomes a place where if in the build stage we're compiling some Maven, doing a Maven deploy of some Java code and we compile some class files, this is a place where we can sort of store those class files and then reference them later when we're doing convergence in our pipeline. And so we do lots of things with the build artifact repository. The reason we do them is because we build once, deploy many times. So this is a notion of taking that set of Java files that you've compiled, putting them in the build repository, and then calling them across the fleet of EC2 instances, say in an auto-scaling scenario. We get to do version control in the space, much like we do in our source version control system. And it also frees us from having to have our build server talk to the instances that are being converged. Right? So there's no need for those things to talk to each other if we're using a sort of an independent third party to pass artifacts through. Some examples of artifacts, there's one here that I'll give you. A scenario that we see sometimes used is taking chef cookbooks and writing maybe a wrapper cookbook or having some sort of cookbook that we commit into a source code repository. We can use on our build server a Burke shelf to vendor that cookbook, which means it will go out to chef. It will go out and assemble all of the chef dependencies in that cookbook into a single package. And we can create a tar file that we can now treat as sort of a build artifact. We can version it and shove it into our artifact repository. And then later we consume it by when the instance is launching, it will call that tar file onto the system, it'll unpack it, and we can run Chef Client in local mode or Chef 0 to deploy it on the instance. So this is an example of something you might store into an artifact repository. Lots of other things we do with build artifacts. Config management platforms like Chef, Puppet, Ansible, which is the example I just gave you, Java, Ruby. You might have Ruby gems stored on that we have to build the Ruby gem during some sort of CI process, and we consume it later when we're installing it places. And even RPMs and other things that we might use more classically in a Linux environment where we would pass packages, install packages through to a converging system. So let's take a quick look. Let's build a simple artifact repository on AWS. We have an Amazon Simple Storage Service, AWS 3, that we can sort of leverage as a very simple way to do artifact hosting on AWS. It's a common pattern that we see. And in the example I'm going to share with you here, we have a build system sort of down in the lower left side of the picture. The build system is going to be running Java, Maven, and Git. So it's a very simple example that we're going to run through. And we've created an S3 bucket in AWS in our account. And so in our Jenkins server, we're going to have a bunch of jobs set up. We're going to be connected to a Git repository somewhere that's going to house some Java code that we want to see brokered into an environment. Once it detects that commit, our build process will then kick off another job that will do a Maven package. The Maven package will assemble a compiled version of our Java, and then we can publish it to S3 with a simple S3 API call. And in this case, we're calling just the put object API. And so we now have this sort of compiled Java code that we've just taken off of our Git repo, and it's out in our artifact repository. And then our build server can then turn around and do an EC2 run instances, which is, again, the EC2 API to launch a set of EC2 instances, and our virtual machines will come up. And when we pass the call, we make the API call, we can pass in user data to that call. And in the user data, we can give instructions or maybe an artifact ID or something that indicates to the building system how to go find the artifact that we've just stashed in our artifact repository. So we could even put bash code in there that could just make a simple call to the S3 API and call the object out of it. Or we could use CF and init or some other capability to reference that artifact from the S3 bucket. So once we've made the EC2 run instance call, our EC2 instances will launch. And the EC2 instances will then connect to the S3 bucket by making an S3 get object call, retrieve whatever the artifact is, and then finish the build process. So very simple scenario. All we really did here was create an S3 bucket, and we have sort of an artifact repository capability. So this is working. So let's take a look at this and see if we're here to talk about techniques that you can implement, artifact, we want to do our build artifacts more like a bank. And so in this case, we're going to look at 3 different things real quick that we can do to make this artifact repository stronger and a little bit more secure. So we're first going to look at implementing some data protection here. So we're going to do some encryption with our artifact repository. We're going to add an entitlement system so that we can ensure that only certain people have access to the artifacts, or certain resources can access those artifacts when we want them. And we'll even add some integrity validation into the system. And so let's look at some of the ways we can do this. So first is encryption. In the encryption space, we have a service, the AWS Kms Service, the key management service, that provides a very seamless way for you to encrypt and decrypt objects using keys, even your own keys. The keys are typically created as called customer managed keys. And you can call against the API and ask the API to encrypt or decrypt something if you have permission to it. And so in this particular scenario, we will pass in simple things like small strings of stuff into a key management service like KMS. But large binary objects typically don't do well in this space. They take a long time to transport, and you'd have to transport it up, wait for it to do some operation, and transport a big, large object back. So because of this, we're talking about a build artifact repository. One of the techniques that we would do to do client-side encryption in this case would be to implement more of an envelope encryption scenario. In envelope encryption, what we classically do is we'll generate a key on the client. We will encrypt the object with the key, and then we will then encrypt the key itself and turn the key into ciphertext that we store with the encrypted object. So in this case, we're going to use the AWS Kms service to do this. We'll make an AWS Kms generate data key call, and that will return 2 key things. There's a bunch of things that get returned from that API, but the 2 elements that we're focused on here are the plain text and the ciphertext of that key. So the plain text is just the open text of the key that we're going to use to turn around and encrypt the object. In this example that I'm showing you, we're going to use OpenSSL. So we're going to make an OpenSSL call with AES-256 encryption, and we're going to pass it in as the key, the plain text that we got back from KMS. The ciphertext, we're going to turn around and store into a tar file with the encrypted version that we just got back from the OpenSSL command into our envelope. And so we can tar these up into a single file. And now instead of passing the unencrypted object into S3, we have a client-side encrypted object that we can pass into S3, and it's encrypted. So going back to our build artifact repository picture, you can see now we're going to inject a third step right after we do the Maven package. We'll inject the third step of KMS generate data key, and we will encrypt that object with our plain text, and create the envelope, and just before the publish, we will encrypt it. And then the other thing I've added here is that you can see, whoops, in the S3 put object call, we've added a flag. SSE or server-side encryption is a flag that you can make, that you can call when you're passing objects into S3, and what S3 will do is we'll turn around and also use KMS. It will use a service-based customer managed key that you can see in your KMS console to encrypt the data that you put into S3 or objects that you're passing into S3 just before they're put into the bucket at rest. And so we call this server-side encryption. So this is something very easy to implement with a simple flag in your S3 calls. So now we've done both client-side and server-side encryption for our artifact into our system. So 2 layers of encryption. The next technique we'll talk about a little bit is entitlement. So let's add a little bit of entitlement system to our simple artifact repository. We've now introduced a new element here. So in the picture, I'm showing you the S3 bucket, but we also have the CMK that we've created with KMS on the right side. And so these are things that when we create them, like when you create an S3 bucket, for example, only the ID that was used to create the bucket is something that can, the owner is the only person that can access that object. What we want to do is we want to create a scenario where we want to entitle EC2 instances at launch, only specific EC2 instances at launch, to be able to talk to or pull objects from our S3 bucket. And so we're going to add to these some resource policies. So resource policies, like IAM policies, are policies that we can associate to particular resources. S3 and KMS happen to be two of the services that support resource policies. What you're looking at here on the left side of the picture is actually CloudFormation. This is the new YAML format for CloudFormation, which we released a couple months ago. But this YAML CloudFormation template actually creates a bucket policy, and it associates it to our S3 bucket. In this particular case, our statement has 2 elements to it that I'll call to your attention. The first one is it's granting S3 get object and S3 get object ACL to a particular principal. And the principal that's referenced there is actually an ARN for another client role that we've created, but we're basically creating this role. We expect that this role is created called artifact client role, and we're going to give that role permission to get object and get object ACLs from our S3 bucket. We're also going to give it the ability to list buckets so that they can see the objects in the bucket. So in this particular policy, we've actually granted permission to get objects from the bucket to a role called artifact client role. Similarly, on the key side, we will create a resource policy for our key that will allow decrypt and describe key. So these are the 2 actions that we're allowing at the bottom of this policy. And again, we're using the same principle here, the artifact client role. So we're giving the artifact client role the ability to pull objects from our S3 bucket and to decrypt objects, decrypt things with our KMS key. So now we go and launch a EC2 server and we ask it to converge. So it's going to call objects from S3 and attempt to decrypt them. And in this case, it's going to be denied because we forgot to launch this instance with an instance profile that was our artifact client role. So let's create that real quick. So here now we have, later in our same CloudFormation template, we're creating an IAM role called artifact consumer is the actual policy name here, but it's get bucket location and list all my buckets. We're also giving it the ability to STS assume role. So this is a very simple thing. We're not actually giving this role any permission to do really anything. We're just referencing this role, which at the very top is called artifact client role. So because it's called artifact client role and referring to that role in the policies that we've created, anything that's associated with this role will be allowed to get objects from the buckets and decrypt with the key. So now that we've associated that to our instance at launch with our instance profile, we've given it the role of artifact client role. It now has the ability to pull objects from the bucket and decrypt with the key. So those are the first 2 techniques where we're going to harden that very simple artifact repository. Let's look at a third one real quick. This one's about verifying the integrity of our artifacts. So this particular one is something that we commonly see in the space, which is around SHA-summing. So what we essentially will do here is we'll use SHA-sum to generate the sum of an object, just to make sure that, and by the way, the summing of an object is a mathematical equation that essentially takes the bits and bytes of a file, and it will pass it through through this algorithm or this equation, and it will always produce the same set of stream of characters at the end. And so the stream of characters can then be stashed into our envelope at the beginning of the process. So when we're building the artifact just before we encrypt it or just before we stash it into our S3 artifact repository, we can grab the SHA-sum of the object and stash that into the envelope. And then later, when we're running through our convergence on the system, it will retrieve and unpack the object. It will decrypt it through KMS. And then we can add a step to verify the integrity of this artifact before we act on it. And the verification of the integrity is simply, let's compare the SHA-sum that was in the envelope with the actual SHA-sum of the object. And if that passes, then we can continue our build process. We can also use a service like DynamoDB, which is a database service that we provide at Amazon, to create a very simple DynamoDB table where we might create an authorization system for our artifacts. And in this particular case, maybe we have a team who's kind of responsible for integrity of things and looking at the security of packages and verifying that things are, or maybe we have some automation in our pipeline somewhere that gives us the ability to maintain this in an automated way. But we could keep basically a database of known good artifacts, right? And so we could add into our system here some automation that would essentially reach out to the system and say, is this artifact known good before I react to it? And if the system says yes, then great, we install. If it says no, then it's blocked. So that's about it for the artifact repository. We're going to go a little bit deeper into the continuous delivery pipeline. So we're going to share a little bit, some more examples of where the pipeline goes. We're going to talk about customizing the pipeline and a couple more tips and tricks here. But to do that, I'm going to bring up Chuck from Stelligent. Chuck Dudley is the Director of Financial Services Accounts at Stelligent. Stelligent is a business partner of AWS's. We work with them a lot in the financial services space, but in a lot of different areas in the enterprise customer space. And so Chuck's going to share a little bit more about what we're doing.
All right. Thank you, Alan.
Thanks, Chuck.
Okay. So build, test, deploy. Pipeline is a pretty simple concept, but a very powerful construct. What this process gives us is that it gives us the ability to ensure that we have consistent, repeatable testing every time there's a code change. It also gives us the ability to have automated deployment that guarantees us that our code is deployed the same way every time. We're no longer concerned with the possibility of human error in the process of deploying. Now, Alan talked about fast feedback in the pipeline. The way that we achieve that is that our pipeline isn't that simple build, test, deploy in implementation, but it's usually comprised of more stages. In our pipeline, we typically create a 5-stage pipeline, which is commit, acceptance, capacity, pre-prod, and production. Commit, we test the code, we analyze the code. Acceptance, we analyze the application. Capacity, we test or analyze the environment. Pre-prod, we build a candidate environment to go into production, do some smoke tests, and then production stage is the process of actually moving that candidate environment into production and the automation around the ability to be able to roll back in case there are some issues. So let's talk a little bit about the commit stage. The goal for the commit stage is to give fast feedback to the developers. Now, in a typical continuous delivery pipeline, we accomplish this through unit tests, through static code analysis, and those kind of processes. But we can go a little further. As Jamie mentioned, one of the important things in our project is to make sure that security isn't something that's bolted on at the end, but it's something that's integrated into the development process at every step. And so we're going to build security into each stage of the pipeline. So one way you can do that is by security static analysis of application code. That might be done with something like Flaw Finder, Brakeman, Lapse, or there's a whole bunch of tools, as many as there are languages out there that you might write application code in. As important as that is to be able to do security static analysis of our infrastructure code. The ability to know what is going to happen ahead of time, or at least get a good idea of it by looking at the code and not relying on actually spinning up resources and then subsequently analyzing them. We're going to do that too, but first we want to be able to essentially ensure that we are not going to expose ourselves unnecessarily with resources that are poorly configured. So what we need to do then is have the ability to do security static analysis of CloudFormation. In order to do this, we need to be able to build a model of what the template is going to produce and then analyze that model. This can be a powerful tool. It helps us to be able to stop bad things before they happen. Unlike with application code, you build your application and then you go run it in a sandbox environment. If there's a security flaw there, you're pretty well sandboxed. But when you're working in the public cloud and you're spinning up resources, you have the ability to accidentally spin up a resource that is going to put you at risk, even though you're in what you consider a sandbox environment. So very important, if at all possible, to be able to prevent those bad things by identifying them before you actually do a create stack. Another very powerful capability that is produced by following this pattern is that it gives your security organization the ability to state their policy as code and therefore very unambiguously. And also for that policy to be consumed essentially by the entire enterprise without depending upon the intervention of a security organization each and every time there needs to be an analysis of the security posture that code generates. So we looked around to find a tool that would help us do this, and we couldn't find a tool out in the marketplace that would allow us to do static analysis of CloudFormation templates and be able to easily consume it in the continuous delivery pipeline. So we went out and wrote a tool. It's called CFN-NAG. It's open source. It can be found on our GitHub repo, and it does exactly what we've been talking about. It inspects the JSON of a CloudFormation template before convergence, before doing a create stack, and identifies potential security problems. The kinds of things that it might find are overly permissive IAM policies or security groups, disabled access logs or disabled server-side encryption. There's a number of rules. It's also extensible so that if your security organization has some specific rules that are important to you, they can be built in too. So now I'm going to do what no rational person should ever do, and that's to do a live demo in front of a few hundred people. So, okay, so what we're actually going to do is go through using CFN-NAG on CloudFormation templates and kind of go through the workflow. This is not built into a pipeline, but as it's a command line tool that returns error codes, it easily can. We've done it in a number of situations. So we have a developer who's written a CloudFormation template that creates a security group. And so at first inspection, this looks like a reasonable security group, right? It's locked down to a single port. That port is locked down to a single address. Rather than trusting instinct, what we can do is run CFN-NAG on that template. And what we find is that this is a failure. So in the context of the pipeline, we stop right here. Stop the line, send notification back to the developer. Your code doesn't pass the smell test. We're not going any further with it. And what we find about this is that there is no egress rule on this security group. Now, unlike ingress, where the default, if no one specifies anything, is to be completely locked down and nothing is open, it's quite the opposite with egress rules. If you don't specify an egress rule, all ports are open to all IPs and can be a potentially fatal flaw if you're concerned about data exfiltration. So we're going to go ahead and we're going to modify this template. And we're going to add an egress rule. So this is some kind of a web server most likely because we're opening port 80 to the world. And now, because we specified this, all other ports are locked down. We're going to go back and we're going to do CFN nag on this again. And now our failure is gone, but we do have a warning. And what that warning is telling us is that this is a very wide open CIDR on the egress rule, port 80 open to the world. Now, we don't fail on this because there are perfectly valid reasons you want to open port 80 to the world. You're creating a web server that you want to be open to the world. But there's also many situations where maybe this isn't really what you intended if you've got an internally facing service. So the developer looks at this and says, yeah, that's not really what I was hoping to do, modifies it, and locks port 80 down to a /16 CIDR block, an internal CIDR block. And now when we run CFN nag again, we end up with no failures and no warnings. Similarly, we might write a CloudFormation template that deals with creating an EBS volume. Again, very simple CloudFormation template. We specify we want to create a volume. We specify the size, the type, the IOPS, where we want it created. But we're not going to trust ourselves that this is a secure template, and instead we're going to go ahead and we're going to run it through CFN nag, and again, we find a failure. And the failure is that this isn't, we haven't specified encryption in this volume. In AWS, encryption is really something that comes for free on EBS volumes. There's really no performance hit. I have a difficult time thinking of any reason why you wouldn't encrypt the volume. So we're going to go ahead and we're going to modify this template. We're going to add encrypted true and run through CFN nag again. And we've got no failures. So as I said, now I've shown it to you through the command line here. It works just exactly the same way in your pipeline. If any of you have created pipelines with Jenkins or other tools, you typically have different test software that runs, that analyzes it. It returns 0 if you're good, returns non-0 if you're bad. We do the same thing, and based on the results of the execution of CFN nag, we decide whether the pipeline continues on and we go to the next stage of the pipeline, or we fail and send notification back to the user. And as you can see, this all happens in a second or two, so it's very rapid feedback that the developer gets. We're going to go back to the slide for a minute. We're going to go to the next stage of the pipeline, and that's the acceptance stage. If you remember what I said before, commit, you test the code. Acceptance, you test the application. So in a typical continuous delivery pipeline, you're going to do things like integration tests and acceptance tests in this stage. Now, in order to do that, you've compiled some code, and you probably need to build some, certainly in AWS, you need to build some infrastructure in which you execute that code in order to be able to test it. But additionally, if we're focused on security in the pipeline, we might want to do something like infrastructure analysis and actually understand what the implications of the resources that we spin up are on our security posture. So the problem to solve here is to prevent infrastructure changes that violate our security policies. And in order to do that, we need to codify our security rules. We also need to get notifications when the violations occur. With infrastructure as code, there's two different ways that a problem can present itself to us. One is that as we go into the acceptance stage and we spin up resources, those resources can actually degrade our security posture. The other thing that's important for us to know in the context of our pipeline is that out-of-band changes, essentially changes through the console, changes through the CLI, might also degrade our security posture. And even though that it wasn't created by our code, we still need to know right away, because it makes the rest of the results that we get back suspect if our environment has changed significantly in an out-of-band way. So, and then finally, the other important thing is that this needs to be able to be something that can be consumed easily within the pipeline. So Amazon has a product called AWS Config, very powerful tool that gives us the ability to analyze our infrastructure and look for security violations, to set up rules that essentially state what our requirements are, and to be able to test against those rules. But enablement of that in the pipeline can be somewhat challenging, and it tends to be a somewhat console-centric tool, particularly in terms of getting the results back and analyzing the results. So we wrote another tool called Config Rule Status, again, an open source tool. You can get it off of our GitHub repo. And it enables us to utilize AWS Config in the continuous delivery pipeline. And how does it do that? Well, one, it essentially bootstraps the setting up of AWS Config, makes it very easy. If you don't have it, it builds it up. The other thing that it does is it creates config rules and Lambda functions to evaluate security appliance, and creates a tester Lambda function in order to be able to consume the results of that infrastructure analysis from within the pipeline. So it has a bundled CLI that allows us to be able to execute this easily, tester function built automatically for you, and it's really easy to invoke from the pipeline. So it utilizes certain core technologies. Obviously, it uses AWS Config. It uses Lambda essentially as the platform for the config rules implementation, CloudFormation to spin up the supporting resources, and the serverless framework for orchestrating the deployment of Lambdas. So this diagram here kind of shows the components to utilizing this in your continuous delivery pipeline. At the top, you see there, we have our deployment pipeline, and the results of utilizing AWS Config and analyzing our environment are going to occur in the acceptance stage of the pipeline. The blue layer there is actually the config service and where the rules are defined and maintained. The Lambda service, the green layer of the environment, is the Lambda functions that implement the rule logic and implement the tester function. And then finally, we have the resources down at the bottom, which are the environment that's spun up for the purposes of our acceptance stage. So. I'm going to not do another live demo, but that's primarily because the actual process of invoking this takes a little longer than I have for this session. So what I'm going to do is show you a screencast of actually utilizing the AWS config service, AWS config and the config rule status. So built into the repo that I talked about has the ability for us to be able to spin up the environment for AWS config. And what's happening now is that we are creating all the resources necessary. The next stage is the actual deploying of Lambda functions for rule logic. And you can see the command there that actually does that. And so right now, we're actually creating the resources necessary, a notification topic, bucket, policies, and roles in order to be able to utilize this. Again, all automatically performed for us. So now what we're actually doing is deploying config so that it will start analyzing the environment for us. And it's populating the rules. You can see there the MFA rule, for instance, is being created here. And here we're going to see some examples of actually utilizing the tool. This first example here is running a Mocha test on a particular environment, and that code there that you just saw flash by, is the code that you might actually write to consume it from within a pipeline. And if you look at the results here, we failed on our initial infrastructure analysis. And when we look at the output of it, we find that we failed because we violated the multi-factor authentication rule. If we look on the console, sure enough, someone has created a user ID out of band that didn't have multi-factor authentication. We go in and we make that change, force them to have multi-factor authentication, run through the test again, and we'll see that we passed. Now, I don't have time to go into the rest of the pipeline in detail, but I will talk very briefly about it. The capacity stage, as I mentioned before, the capacity stage is where we test the environment. In other words, we want an environment that looks like what was going to go into production so that we can make sure, for instance, that it's performant. So we might run performance tests, load tests, really, real-world testing of the environment that we're going to create. Now, in terms of adding security to that stage of the pipeline, there's a couple of different things we might want to do. We might want to, for instance, do automated penetration testing using something like the OWASP Z attack proxy. We might want to go into detail and analyze the configuration of any instance we create from a point of view of the OS and software configurations. The production stage, as I mentioned, is actually, there's two phases to the production stage. One is pre-prod, where we build the candidate environment that we expect to go into production. This assumes that everything else is passed in the pipeline. Once we build it, we'll do some smoke tests to make sure that everything is working as expected, essentially a repeat of a lot of the testing that's happened before. And then we're really making a go, no-go decision about whether to go to production. If we go to production, then the second phase of the stage is to actually take the candidate environment, make it production, and to hold the previous production environments in abeyance in case there are some problems that are noticed when we first go up, so that we can switch back rapidly. So another important concept here is that, as I mentioned earlier, in addition to changes that we invoke through our code, we also have to be concerned with out-of-band changes that might affect our security posture. So the same kind of testing that we do in the acceptance phase, in the capacity phase, if you're doing this securely, should become your monitoring or part of your monitoring in the production phase. Essentially, you want to make sure that your security posture is maintained. The other important thing is that the information that we're collecting by continuing to do this testing or monitoring results in valuable metrics that can actually feed back and allow us to even further tighten down our security requirements or otherwise influence the tests and requirements that we have for security. So all of the tools that I've talked about here, the code that I've talked about, and a number of blog articles are all referenced on this page, stelligent.com/fin303. And so, I encourage you to take a look and, utilize them and contact us. I'm going to now give it back to Alan.
Great. So thanks, everybody. And so we just went through a few quick tips and tricks, but just wanted to sort of close out a little bit. These are some of the things that we're sort of doing in combination, in collaboration with Citigroup, as they're working through sort of modernizing their continuous delivery capabilities. Right? These are techniques that hopefully you can take home and leverage in your own systems, and we hope you enjoyed it. Jamie, Chuck, and I will hang out here a little bit for questions, so feel free to come on up and see us. Thanks.